Alright, so today we're presenting a presentation about the performance of the internet. My name is Jake Parrish.
And my name is Haley Mehta. So today for our experiment, we'll be looking at how long a packet takes to get from the host to the routers using traceroute. And we've used three different websites for this experiment. And those are Stanford, Bloomberg, and
Edinburgh.
We will not, we'll note the average, max, and minimum times for the packets, and also note any interesting observations that we find for packets lost.
So to do this, we'll be sending pings to the routers along the trace route. We'll do this 60 times in a minute for 1 day and during 5 times of the day. So the 5 times are morning, mid-morning, midday, evening, and night. And so we'll also observe any differences between the performance in regards to time between these times of day. So here's the trace route to stanford.edu. So the results of these pings, the average time. Here's the min times for stanford.edu. The max time. And so analysis of some of these charts. So first, it's just important to note that California is 3 hours behind. So I took that into consideration when thinking about the busiest times of the day for the server. So mid-morning seems to be the busiest time, followed by the night and evening. Therefore, for the California one, I believe the morning would be the busiest. It's also interesting to note that for the max times, the night is the highest because there seems to be a lot of outliers during that period of day, and the min times are also the highest, but it's not for the average times. So that was one interesting thing to note. Here's the trace route to Edinburgh, which is in the UK. So here's the result of the pings, the average times. So here it's also interesting to note that as we move along the trace route, the average time continues to go up. And that makes sense because the routers get further away. So it makes sense that it takes a little bit more time. And here's the min times. The max times. And a little bit of analysis for these times. So Edinburgh, as I said, it's in England, so it would be 5 hours ahead. So that's important to keep in mind when looking at the times for the internet traffic. So the longest time seems to be in the early morning. It's also interesting to see that for the nighttime, there seems to be very large outliers, as there was for Stanford. And then, as I said, as we move further along the trace route, the average times seem to get a little bit longer, which makes sense as the pings are further away.
So this is the trace route for Bloomberg.com, and this is the result for the average time. This is the result for the maximum time observed, and this is the time observed for the minimum time. So when looking at the charts, we observe that most of the routes are busiest during the morning and the night, and the average times during mid-morning are the least, as shown here. One interesting anomaly that we note is that for router 10, the average time during mid-afternoon is unusually high. This could be a result of either the traffic at that particular router, or due to congestion in the link, or due to congestion of the router for processing the packets. And we also note that the maximum time for router 5 was unusually high during morning and night than the other times of the day. The reason for this could also be that either there was a lot of congestion at the router, or just there was a lot of processing delay. And the maximum time for router 6 was also unusually high during mid-afternoon and any other times of the day. For minimum times, we do not observe any interesting anomalies. And that's it for Bloomberg.com. So one particular thing that we found is that if you look at the trace routes for all of the 3 websites, the ping to the second last router always dropped 100%. So there was a packet loss of 100% of all of those routers. So while looking at reasons for this, we thought that there's one possibility that there's a firewall set up at the router that blocks all the ICMP packets, and hence when any pings are sent to those routers, it just blocks them and it doesn't reply. So as an example, if you look at the trace route for Bloomberg.com, the second to last hop is 103.244.50.118. And out of the 3 requests, we see that only 1 reply is received and the subsequent requests are blocked. This was only one of the reasons that we could find or think of for this interesting anomaly.
So some of the conclusions that we drew. So one of the busiest times for all 3 of the sites, or the busiest time seemed to be the early morning. And there could be many different reasons for this. Maybe for Bloomberg it's because people are, starting the financial day, so they're looking at different financial information, and so different stuff like that. And then the average times are clearly longest for the further away servers, so for Edinburgh, then Stanford, and then Bloomberg.com. And then, as we just said, the one interesting anomaly we found was that the second to last hop on each website did not respond any of the packets when we pinged them. And this could be to the way that traceroute operates or the other reasons that we mentioned before.